So this is our first practical. Okay. Okay. So we will start with the practical. My screen is visible to all. Yes, Pratiksha.
Yes, ma'am.
I asked you to come in the lab. Why you are not coming? Okay. So we will start. So today we will discuss about the practicals which we are going to study for this optical communication subject. So basically this optical communication subject, it is having the practical along with its performance. Okay. So there are total actually 10 practicals. I will show you the lab manual as well as list of the practicals, and we will discuss upon the particular kit on which we are going to perform the practical and the basic concepts related to the practical. Okay, so you just give me 1 minute. So I have added the lab manual in your study material. So I request all of you to go through that lab manual to understand the basic things. Okay, just 1 minute. So are you able to see this, my screen? Is it visible to all?
Yes, ma'am.
Okay. So this is the lab manual of optical communication. So if you see the basic part, initially the pre-lab concept it is given. Pre-lab means what? For understanding the practicals, which parameter you should understand. Basically, that concept it is given in the pre-lab. And here if you see, I am trying to show you the kit. You just check how much it can be properly visible. So this is the practical kit on which we are going to perform the optical communication related practicals. Okay, so pre-lab means that is the introductory part which is required to be understood by the students. So in pre-lab part, if you see, there is theory of optical fiber, how it works, then refractive index means what, ray theory of light for basic working principle of optical fiber, total internal reflection, ह्या सगळ्या गोष्टी ह्या बेसिक प्री-लॅब पार्ट मध्ये आहेत. देन हियर इट इज द ऑप्टिकल फायबर कम्युनिकेशन system, its block diagram it is shown. So all the things are there in this basic part. Now here is list of the experiments. So total there are 10 experiments given. Out of that, at least minimum 8 experiments we are going to perform for this optical communication subject. Okay, so briefly I will discuss about the experiments. So first experiment it is, okay, my voice is audible and screen is visible to all.
Yes, ma'am.
So first it is setting up fiber optic analog and digital link. So basically in first experiment, we are going to transmit the analog signal as well as digital signal through fiber optic cable. Okay, so if you see, I will show you the fiber optic cable. So this wire, if you see, this is the fiber optic cable. Visually जर तुम्ही बघितलं तर it looks like our regular coaxial cable, but now I am connecting that fiber in front of some light, or I am connecting it in front of the optical source. So in that case, when I connect it in front of the optical source, we are able to see the light coming out of the optical fiber cable. Okay, so suppose here you will be able to see this. Just 1 minute. So this is the kit of optical fiber cable. So there is one optical source which is emitting the red color light. So you just, I will show you that optical fiber cable. If I connect it on that optical source, are you able to see this red light coming out through the optical fiber cable?
Yes, ma'am.
So I have connected the fiber now in front of that red LED. That's why I am able to see this red light. Now this fiber, if I hold in front of simple natural light, if I am not holding any, if I am not allowing any light to enter here, this side also you will not observe any light. पण हे जर मी इकडून जो नॅचरल लाईट येतोय त्याच्या पुढे जर मी फायबर केबल धरला तर at another end you are able to see the white light. दिसते का white light तुम्हाला? Because I have hold this fiber in front of the window, and from that window the natural light is coming. So here you are able to see the white light. Another example, on the kit there is one green LED. So if I hold the fiber in front of green LED, here you are able to see the green light coming out through this fiber optic cable. Similarly, ज्या लाईटच्या पुढे आपण हा फायबर केबल धरतो, that same light you will be able to see coming out through the fiber optic cable. Okay, so I will show you that kit also. So I will hold that mobile there and I will show you through the mobile camera. So first experiment is to transmit analog link and to transmit the analog signal and digital signal through fiber optic cable. That is first experiment. Then second experiment is frequency modulation using fiber optic cable. So frequency modulation using fiber optic cable means FM signal we are going to generate, and that FM signal we are going to transmit through the fiber optic cable. That is the second experiment. Third one, it is pulse width modulation using fiber optic cable. So we are going to generate the PWM signal, and that PWM signal will be transmitted through the fiber optic cable. म्हणजे पहिल्या 3 एक्सपेरिमेंट मध्ये काय बघायचं आपल्याला? We have to see the transmission of analog signal and digital signal, then transmission of FM signal through fiber optic cable, and transmission of PWM signal through fiber optic cable. This is about first 3 experiments. Then fourth, okay, clear that first 3 experiments what we are going to see? Is it clear? First 3 experiments what we are going to see? Are you clear with this? Is it clear? First 3 experiments you are going to perform the you are going to perform the practical based on the transmission of the various signals. Then experiment number 4, 5 and 6 and 7. हे जे 4 experiment आहेत, these 4 experiments are related to the different parameter calculations in the optical fiber. For example, in this 4th experiment, we have to study the propagation loss, how to calculate the propagation loss in optical fiber, then study of bending loss. So it is very simple. When the optical fiber cable is bent, obviously the amount of light coming out from that optical fiber, it is going to be reduced. So bending losses are going to take place in the optical fiber. That is experiment number 5 we are going to see. First, चौथ्यामध्ये आपल्याला propagation loss calculate करायचे. 5th मध्ये bending loss we have to calculate. Then in experiment number 6 we have to calculate the optical power. So measurement of optical power using the optical power meter. Okay. So here we have to measure the optical power. So I will show you one device which is called as optical power meter. So like multimeter, on that we are measuring the current, voltage. Similarly, optical power meter is the device on which we can measure the optical power. Okay, so that is experiment number 6. So I will just show you that device. Wait for 1 minute. Okay, so this is the device called as optical power meter. Here if you see, you can read here optical power meter. So it is having one slot. In that slot, one end of optical fiber it is attached and another end of optical fiber it is attached on the kit in front of optical source. And this reading here will be displayed for the optical power. So that is optical power measurement. Then next is measurement of numerical aperture. Now in theory part we have seen the numerical aperture concept. So can anyone tell what is the meaning of numerical aperture? Numerical aperture means what we have seen in the first chapter. Derivation also we have derived and some numericals also we have solved. So can you tell what is the meaning of numerical aperture? Yes. Give the answers. Minal, can you tell what is the meaning of numerical aperture? Numerical aperture means what? Pratibha, Pratiksha, Smita. बघितलंय ना आपण फर्स्ट चॅप्टर मध्ये. व्हॉट इज न्यूमरिकल अपर्चर मीनिंग? काय डेफिनेशन त्याची? इट इज लाईट कलेक्टिंग ॲबिलिटी ऑफ ऑप्टिकल फायबर. त्याचं इक्वेशन बघितलंय आपण. Na is equal to n1 square minus n2 square. Okay, largest angle at incident ray can have for total internal reflection. Okay, that is acceptance angle, whatever you are saying. But numerical aperture is the light collecting ability of optical fiber. In some references that may be correct, whatever definition you have given, but it is actually defined as the light collecting ability of optical fiber. Okay, then that practically we have to measure. म्हणजे theoretically एखाद्या फायबरची व्हॅल्यू काढली तर प्रॅक्टिकली काढून आपण कंपेअर करू शकतो. Then next is transmission of voice signal through fiber optic cable and transmission of computer signal through fiber optic cable. म्हणजे पहिले 3 एक्सपेरिमेंट आहेत हे इलेक्ट्रिकल सिग्नल ट्रान्समिशन शी रिलेटेड आहेत. नेक्स्ट जे 4 एक्सपेरिमेंट आहेत ते मेजरमेंट ऑफ ऑप्टिकल फायबर पॅरामीटर्स शी रिलेटेड आहेत. And experiment number 8, 9 and 10, those are related with transmission of non-electrical signal, voice. So आपण जर एका mic मधून बोललो and that voice if you transmit through fiber optic cable, you are able to hear it properly at the receiver end. That is the transmission of voice signal using fiber optic cable. तिथे आता पहिल्यांदा voice चं electrical signal मध्ये conversion होतं mic through. Then that electrical signal is converted in the form of light through optical source. Then it is transmitted through fiber optic cable. At receiver again, the light is converted in the form of electrical signal through detector, and again that electrical into voice through loudspeaker. Like that, it is very interesting experiment that is there. Through mic we are speaking and the same signal we are transmitting through fiber optic cable. Then next is transmission of computer signal using fiber optic cable. One transmitter, that's RS-232 port आहे, and another computer, so RS-232 port. Through that two ports we are going to connect to the kit, and then we are going to transmit the computer signal through fiber optic cable. And last one, it is characteristics of fiber optic communication link. So we will see at least first these 8 experiments we are going to take. About these 2 experiments we can consider later. So did you get the overall idea about the practicals, what we are going to see? At least basic part, is it clear to you? काय काय बघणार आहे आपण एक्सपेरिमेंट, कुठले एक्सपेरिमेंट बघणार आहे? प्लीज गिव्ह सम रिस्पॉन्सेस. प्रतीक्षा, समजलं का प्रॅक्टिकल मध्ये काय बघणार आहे ते?
Yes, ma'am.
So transmission of signal, electrical signal, then calculation of various parameters of optical fiber cable, and then next transmission of the non-electrical signal. एवढा आपण ह्या एक्सपेरिमेंट मध्ये बघणार आहे. Again, the practicals are very simple for this optical communication subject. आता AC PDC मध्ये कसं असतं, प्रत्येक प्रॅक्टिकल साठी डिफरंट किट यूज करावं लागतं आपल्याला. But for this optical communication subject, same kind of kit, means quantities are more, but kit required it is only one type of kit. आणि त्या एका टाइपच्या किट वरती तुम्ही हे सगळे एक्सपेरिमेंट परफॉर्म करू शकता. So I will first show you that kit. I will hold the camera in front of the kit and I will try to explain. Let us see how much we are able to understand it. So first experiment is setting up fiber optic analog link and digital link. So for this first experiment also, it is mandatory to understand the basic things. So I will first show you the kit to mobile and let us try to understand the main blocks. At least initial level I will explain you the main blocks, because there are number of blocks on the kit, but all are not required for the first experiment. First experiment साठी जे लागणार आहेत block, that only at least I will explain today. Okay, so you just wait for 1 minute. Wait 1 minute. बघा आता इथे सांगा मला किट दिसतंय का तुम्हाला? Are you able to see the kit whatever is here? Are you able to see that? Give some responses. Say yes, no. आता इथे लिहिलेलं आहे फायबर ऑप्टिक ट्रेनर किट Syntec ST2502. So this is name of the kit on which we are going to perform our optical communication related practicals. Now this is the optical power meter, whatever you are able to see here. and the very basic part, that is optical fiber cable. So this one, it is the optical fiber cable. So I will explain you the blocks one by one of this particular kit. So actually I had made connections for performing practical. So let me explain first all the blocks and then we will start performing the practical. Now I will make this kit on. Here first block, it is power supply. This is power supply switch. Then this is function generator. Now you compare this block with the block diagram of optical communication system. आपण optical communication system ची जी basic block diagram बघितली आहे त्याच्यासोबत compare करा हे kit. So first block, it is function generator. So function generator is nothing but the information source. So it is generating the electrical signal for next transmission purpose. आता इथं बघा कुठले कुठले सिग्नल दाखवलेले आहेत फंक्शन जनरेटर मध्ये. Are you able to see that? Here function generator, which two signals are shown? हा कुठला सिग्नल आहे दाखवलेला इथं? Analog or digital? This first I am asking. Which signal this is? Analog or digital? This one. कुठलं आहे सिम्बॉल? अॅनालॉगचं आहे का डिजिटलचं आहे? Yes, Smita. This is of analog or digital signal? Give the answer. So this is the analog signal and this is the digital signal. So this function generator is generating analog as well as the digital. So this is the, just a minute. This is the analog signal and this is the digital signal. So this function generator is generating both analog as well as the digital signals. Then this is first basic block, function generator. Then here, are you able to see this light? Actually this is a red color light, but through this mobile camera you may feel it as a white light, but this is basically the red color light. So are you able to see that?
Yes, ma'am.
So that is emitter section. आता हे जे आहे frequency modulator आणि PWM modulation हे second आणि third experiments साठी लागतंय. So I am not explaining all the blocks right now. Only basic blocks I am explaining. This is function generator which generates analog signal as well as the digital signal. Analog signal amplitude ह्या पॉटने आपण चेंज करू शकतो and ह्याची frequency आहे 1 kilohertz. So it is written here. Its frequency is 1 kilohertz. Similarly, for this digital signal also the frequency is 1 kilohertz. So amplitude of the analog signal can be changed, but amplitude for digital signal it cannot be changed. It is 5 volt peak to peak fixed value. So this is first block, function generator. I hope you are clear. And हा जो खाली block आहे, this is the power supply block. It is generating the DC power supply which is required for the next blocks for its operation. Then this is emitter circuit. Emitter, this is nothing but the ट्रान्समीटर. आता फॉर एक्झाम्पल आपला जर पहिला एक्सपेरिमेंट आपण बघितला, आपल्याला अॅनालॉग सिग्नल ट्रान्समिट करायचं आहे, तर व्हॉट आय विल डू, I will take this analog signal and I will connect this patch cord. This is called as patch cord, which connects the two blocks. So I will take the analog signal from this point and I will give it as input to the emitter circuit. See, this analog signal I have taken here from here and I have given it as input to the emitter circuit. The emitter circuit मध्ये काय असतं? This is the driver circuit. So what this driver circuit it does, it transmits the signal as it is. हा जो इलेक्ट्रिकल सिग्नल आपण दिलेला आहे, हा इलेक्ट्रिकल सिग्नल तो as it is ऑप्टिकल सोर्स पर्यंत नेतो. आता हा जो इथे एलईडी आहे, so here if you see it is written emitter LED. So this LED is acting as a optical source. So this question may be asked in the oral, that which optical source it is used in the kit. So LED is used as an optical source in the kit. So this is the LED. This LED converts this electrical signal in the form of light. So this is our main transmitter part. And again there is one more switch, analog and digital. So you have to always keep it on the analog mode. Otherwise this light you will not be able to see. So analog signal आपण इथून घेतला and that we have connected to this emitter as its input, and here we are getting that electrical signal is converted in the form of light. समजलं का? बेसिक पार्ट तुम्हाला काय सांगितलं मी आता, इन्फॉर्मेशन सोर्स आणि ट्रान्समीटर हे दोन ब्लॉक आपण एक्सप्लेन केले. ट्रान्समीटर is nothing but it is also called as emitter circuit. Whether these two blocks are clear? Yes.
Yes.
पहिले बेसिक दोन
Yes,
ब्लॉक
ma'am.
समजले का? आता इथे आपला फायबर आपण कनेक्ट करणार आहे. हा इमिटर आहे and this is the detector. So in between the emitter and detector we are going to connect the optical fiber cables. I will make it off so that you will be able to see. इथे हे एक स्लॉट आहे. This is transmitter and this is receiver. So in between the transmitter and receiver we are going to connect our fiber optic cable. So this is the fiber optic cable that we are going to connect. तुम्ही जर व्हिज्युअली बघितली तर डोळ्याला ती आपल्या रेग्युलर केबल सारखीच दिसते, but there is optical fiber inside it. See, आता इथं मी रेड कलरच्या लाईटला हा फायबर लावलाय, त्यामुळे दुसऱ्या एंडला मला सेम लाईट इथं दिसते. So this light, this fiber I will connect to the detector as input. So this is transmitter, this is receiver. मग आता इथं डिटेक्टर सर्किट दिलेले आहे. So this is using photo transistor as an optical detector. So optical source म्हणून आपण LED वापरलाय आणि optical detector म्हणून काय वापरलाय आपण? We have used the photo transistor as an optical detector. So this analog signal is given here. Then it is given to LED. LED will convert it in the form of light. That light we have passed through fiber optic cable and given to the detector. आता ह्याच्यामध्ये जो photo transistor आहे, what that photo transistor will do? It will convert again the light in the form of electrical signal. So here whatever signal you will get, that you will get in the form of electrical signal, but that signal it is not having the more amplitude because of losses in the optical fiber. म्हणजे इथं पण तुम्हाला परत analog signal मिळतो, but as it is having some losses, to cover that losses we have to amplify this signal. त्यामुळे हे इमिटरचा डिटेक्टरचा आउटपुट आपण कुठे देतो? Afterwards the detector's output is given to this AC amplifier circuit. So there are only 3-4 connections. Right now I am discussing about first experiment. First experiment is setting up analog link and digital link. त्याच्यापैकी आपण आता analog link बघतोय. मग analog link मध्ये काय केलं आपण? I will show you the waveforms later on one by one. First we have taken the analog signal. कुठे दिला तो analog signal? पहिल्यांदा आपण emitter circuitच्या इनपुटला. emitter circuit मध्ये ड्रायव्हर आहे, ऑप्टिकल सोर्स आहे. ऑप्टिकल सोर्स will convert that electrical signal in the form of light, then it is transmitting it, then it is given to the detector. Again, detector will convert the optical signal in the form of light through this photo transistor, and then it is obtained in the form of electrical signal here, but due to the losses in the optical fiber, ह्या सिग्नलचा एम्प्लिट्यूड किंवा स्ट्रेंथ त्याची काय असते, कमी असते. त्यामुळे तो आपण कुठे दिला, पुढं इमिटरचा डिटेक्टरचा आउटपुट आपण कुठे दिला, एम्प्लिफायरला. आणि ह्या एम्प्लिफायरच्या आउटपुटला जो तुम्हाला मेन सिग्नल मिळेल, that will be your original analog signal. So these are the connections for analog link. So whether the connections are clear?
Yes, ma'am.
Now we will see the waveforms one by one. Actually, I required some help for this. That's why I was asking Pratiksha to be in the campus, because I have to show the waveforms also, and it is not possible. It is somewhat critical to do that two tasks simultaneously, holding this mobile and showing the waveform. Okay, still I will try. You just wait for 1 minute. See. This is analog signal. आता इथं मी probe connect करते. This is the digital storage oscilloscope. So on this oscilloscope, we have to check our waveform. आता हा analog signal आहे. मग this is DSO and this is the DSO probe. So for probe, there are two terminals. One is black and another it is red. So black terminal जे आहे ते नेहमी ग्राउंड ला कनेक्ट केलेलं असतं, आणि रेड टर्मिनल इज ऍक्च्युअली कनेक्टेड टू द पॉइंट वेअर वी हॅव टू सी द सिग्नल. आता आपल्याला अनालॉग सिग्नल बघायचा आहे, त्यामुळं हा प्रोब मी इथं कनेक्ट केला. मग त्या प्रोबची जी ब्लॅक कलर आहे ते टर्मिनल मी ग्राउंड ला कनेक्ट केलं इथं बघा. So this point it is here. If you see on kit, this is written as 0 volt. So this is the ground. So I have connected it here, and this one it is the point of analog signal. So now I will check the waveform on the DSO. Okay, so just 1 minute. बघा आता ह्या DSO मध्ये आपण चॅनल 1 बघतोय. So here is one button called as auto set. So if you press that auto set button, all the scales, time as well as voltage, that scales are adjusted automatically and we are able to see the waveform. आता हे analog signal ची frequency किती आहे मला सांगू शकता का कोणी बघा? I had told you initially. तुम्हाला kit वरती दाखवलं होतं मी सिग्नल. किती आहे त्याची frequency सांगा मला analog signal ची. I had shown you no on the kit initially. The analog signal. What is its frequency? Can you tell me? Yes. Frequency सांगितली होती ना analog signal ची किती आहे ह्या kit वरती. जो काही analog signal आहे किंवा digital signal आहे त्याची frequency किती आहे? So this yellow color, whatever you are seeing, that is the input analog signal. This yellow color signal. And here, if you measure the parameters, so automatically it is displayed. So frequency it is. So I will just change here channel 1. So channel 1 चे parameter येतात. So channel 1 is having frequency as 1 kilohertz. आता इथे दोन चॅनल आहेत, ह्यातल्या कुठल्या चॅनलला आपण मेजर करतोय आपली सिग्नल आता? फर्स्ट चॅनलला. त्यामुळे इथे आपल्याला चॅनल 1 चे स्पेसिफिकेशन पाहिजे. So this is having frequency as 1 kilohertz. मग आता हा जो नॉब आहे इथला, ह्या नॉबनी तुम्ही ह्या सिग्नलचा व्होल्टेज चेंज करू शकता. So you can see here, you focus on yellow waveform. Don't see the another waveform because that is related to channel 2. So you just focus on this yellow waveform. So for this basic analog signal, बघा इथून ह्या पॉट थ्रू मी त्याचा एम्प्लिट्यूड आता 0 केले. If I slowly increase it, you can see it. इथेच एम्प्लिट्यूड वाढते. And last amplitude which you can get, that is 10 volt peak to peak for this analog signal. So this is the, just 1 minute. So this is our basic input signal, basic analog signal जो आपण ट्रान्समिट केलाय तो आपण बघितला आता. मग आता हा एनालॉग सिग्नल इथे इलेक्ट्रिकल फॉर्म मध्ये आहे. इथे गेला, स्टिल हियर ऑल्सो इट विल बी इन इलेक्ट्रिकल फॉर्म. Here it is converted in the form of light through this LED. Again here it is also in the form of light, but through this detector. Detector मध्ये कुठला optical detector वापरलाय? Photo transistor, that is converting this light in the form of electrical signal again. So here if you see, इथं कुठल्या फॉर्म मध्ये मिळेल आपल्याला सिग्नल सांगा. या रेड कलरच्या पॉइंटला इलेक्ट्रिकल असेल का ऑप्टिकल असेल? डिटेक्टरच्या आउटपुटला कुठल्या फॉर्म मध्ये मिळेल आपल्याला सिग्नल? Whether it will be in the form of light or it will be in the form of electrical signal. Yes. इथं कुठल्या फॉर्म मध्ये मिळेल सांगा मला सिग्नल? डिटेक्टरच्या आउटपुटला. हा प्रतीक्षा.
लाईट मॅम.
डिटेक्टरच्या आउटपुटला सिग्नल आपल्याला इलेक्ट्रिकल फॉर्म मध्ये मिळेल. सोर्सच्या आउटपुटला आपल्याला लाईटच्या फॉर्म मध्ये मिळतो. बट डिटेक्टर इज कन्व्हर्टिंग अगेन दॅट लाईट सिग्नल इन द फॉर्म ऑफ इलेक्ट्रिकल सिग्नल. सो ऍट द आउटपुट ऑफ डिटेक्टर, आय एम नॉट आस्किंग आउटपुट ऑफ ऑप्टिकल सोर्स. ऑप्टिकल सोर्सच्या आउटपुटला इथे आपल्याला लाईटच्या फॉर्म मध्ये मिळतोय. ओके, बट अगेन इट इज पास्ड हिअर and this detector is converting this light signal in the form of electrical signal. So here we are getting it in the form of electrical signal only. आता मग मी इथं जर लावला प्रोब ह्या पॉइंटला डिटेक्टरच्या आउटपुटला, तर बघा आपल्याला इलेक्ट्रिकल सिग्नलच दिसतो इथं, पण त्याचा एम्प्लिट्यूड काय झालेलं आहे? कमी झालेलं आहे. बिकॉज ऑफ when you are passing that light through fiber optic cable, losses take place. That's why its amplitude it is reduced, and that's why again it is passed through the amplifier. आता जर amplifier च्या आउटपुटला तुम्ही बघितलं तर now we will compare the two signals. आता हा येलो कलरचा आहे, हा आपला इनपुट सिग्नल आहे. देन आउटपुट सिग्नल कुठे मिळणार आहे आपल्याला? एम्प्लिफायरच्या आउटपुटला. फायबर ऑप्टिक केबल मधून पास केल्यानंतर फायनल आउटपुट सिग्नल जो आहे that we are going to get here. हे बघा, हा ओरिजिनल सिग्नल इथे आहे, ह्याला मी पहिला प्रोब कनेक्ट केला, आणि फायनल आउटपुट सिग्नल आपल्याला कुठे मिळणार आहे? एम्प्लिफायरच्या आउटपुटला. एम्प्लिफायरला का दिला आपण सिग्नल सांगा मला? का दिला आपण एम्प्लिफायरला सिग्नल? डिटेक्टरच्या आउटपुटलाच आपल्याला इलेक्ट्रिकल सिग्नल मिळत होता ना. बट व्हाय वी हॅव गिवन इट टू द एम्प्लिफायर, दिस ब्लॉक AC एम्प्लिफायर सर्किट. ह्या डिटेक्टरचा आउटपुट आपण एम्प्लिफायरला का दिलं? इथं मिळणारा इलेक्ट्रिकल सिग्नलचा एम्प्लिट्यूड कमी होतं का जास्त होतं डिटेक्टरच्या आउटपुटला? डिटेक्टरच्या आउटपुटचा सिग्नल त्याचा एम्प्लिट्यूड कमी होतं का जास्त होतं? Whether it was up to the mark or it was less. सांगा. आता बघितलं ना आपण, हे बघा आता तुमच्या समोरच मी हे काढते, इथलं काढते प्रोब आणि ह्या डिटेक्टरच्या आउटपुटला जोडते. बघा आता ह्या निळ्याचा एम्प्लिट्यूड कमी आहे का जास्त आहे? निळा म्हणजे आपला आउटपुट आहे, आणि ब्ल्यू म्हणजे सॉरी, ब्ल्यू मीन्स आवर आउटपुट and that yellow is our input. So that whatever is the output at detector, that is of less amplitude or more amplitude? Less amplitude. हे बघा हा येलो सिग्नल आहे ना, हा तो आपण ह्या ओरिजिनल हा पहिला प्रोब आहे. इथं जर डीएसओ बघितलं तर त्याला 2 प्रोब आहेत. दिस फर्स्ट प्रोब वी हॅव कनेक्टेड टू द बेसिक इनपुट सिग्नल पार्ट इकडे फंक्शन जनरेटरला, आणि हा जो दुसरा प्रोब आहे तो मी आउटपुट पार्टला जोडते, किंवा स्टेप बाय स्टेप आय एम कनेक्टिंग द सेकंड प्रोब. आता हा जर मी डिटेक्टरच्या आउटपुटला जोडला तर इथं व्होल्टेज कमी आहे, बट सेम output if I am measuring at the amplifier's output, now it is amplifier च्या आउटपुटला वाढले का कमी झाले सांगा मला आता? वाढले. मग त्यासाठीच आपण इथे एम्प्लिफायर केलेला आहे, कारण फायबर ऑप्टिक केबल थ्रू आपण इन्फॉर्मेशन हा एनालॉग सिग्नल पास केला, पण फायबर ऑप्टिक केबल मधून पास करताना त्याच्यामध्ये लॉसेस निर्माण झाल्यामुळे डिटेक्टरच्या आउटपुटला आपल्याला analog signal मिळतो, but that is not having sufficient amplitude, that it is having losses, that's why we are again giving it to the amplifier. आणि आता amplifier च्या आउटपुटला जो आपल्याला मिळतो तो आपला फायनल सिग्नल आहे. आता हा येलो कलरचा आहे, हा ओरिजिनल इनपुट आहे, आणि हा ब्ल्यू कलरचा आहे तो आपला फायबर मधून पास करून एम्प्लिफायरच्या आउटपुटला मिळालेला सिग्नल आहे. आता दोन्ही इनपुट आउटपुट सेम दिसतात का तुम्हाला सांगा ग्राफ मध्ये? म्हणजे आपल्याला काय प्रूव्ह केलं आपण इथं, की जो काय आपला ओरिजिनल अॅनालॉग सिग्नल आहे तो सेम सिग्नल आपण फायबर ऑप्टिक केबल मधून पास करू शकतो. दॅट इज ओनली नथिंग बट कॉल्ड एज अॅनालॉग लिंक. Analog link means what? Analog signal we are transmitting through fiber optic cable, that we are calling it as a analog link. मग आता इथं बघा मी काहीच कनेक्शन कुठल्याच चेंज करत नाही. जस्ट इफ आय डिक्रीज द इनपुट, आउटपुट पण काय होतं ह्या केस मध्ये बघा. आता मी इनपुट 0 केलं, येलो इज इनपुट. इफ आय मेक द इनपुट 0 विथ दिस स्पॉट, आउटपुट इज ऑल्सो 0. मी ज्या ज्या प्रपोर्शन मध्ये इनपुट वेवफॉर्म चेंज करते त्या त्या प्रपोर्शन मध्ये इथं काय होते, आउटपुट वेवफॉर्म चेंज होते. इज इट क्लियर? मीन्स वॉट एव्हर सिग्नल वी आर ट्रान्समिटिंग, सेम सिग्नल वी आर गेटिंग एट द रिसीवर थ्रू दिस फायबर ऑप्टिक cable. That only we have to prove in this setting up analog link experiment. Is that clear? Can anyone just tell me what connect? हा समजलं का एक्सपेरिमेंट सांगा मला.
Yes, ma'am.
काय केलं आपण ह्या एक्सपेरिमेंट मध्ये? समराइज करा फक्त, काय काय समजलं तुम्हाला ह्या एक्सपेरिमेंट मधलं? हा, गिव्ह सम आन्सर प्लीज एनीवन. काय काय समजलं ह्या एक्सपेरिमेंट मध्ये? काय केलंय? कुठला सिग्नल ट्रान्समिट केला आपण, कशातून? हा, लेट इट बी रॉंग, प्लीज ट्राय टू गिव्ह द आन्सर्स. Give the answer. What we have studied in this experiment. Yes, Minal, can you tell? At least you are trying, that is good. What we have done in this experiment, Minal? Pratiksha. We have transmitted the analog signal through fiber optic cable. So connections which we have made, analog signal taken, that is connected to the emitter. Emitter मध्ये driver circuit ह्याला LED पर्यंत नेतो. Then LED is converting the electrical signal in the form of light. हा झाला transmitter part. इथं आपण एक fiber optic cable connect केली. Then it is given to the detector. Detector will convert the light in the form of electrical signal again, but its amplitude is less. That's why detector's output is given to the amplifier and its gain it is increased. And now whatever input output you are seeing, बोथ आर सेम. आता ज्या प्रपोर्शनेट मध्ये मी इनपुट चेंज करते बघा, आता इथं मी बाकी काहीच कनेक्शन हलवत नाहीये, फक्त इनपुट जर मी चेंज केलं तर सेम प्रपोर्शन नेट मध्ये आउटपुट चेंज होताना दिसतंय का तुम्हाला? दिसतंय का नाही?
Yes.
Means whatever signal you are transmitting, same signal you are getting at the receiver side. Means successfully you can transmit the analog signal. कशातून पास केला आता आपण? हा फायबर ऑप्टिक केबल मधूनच पास केला ना. पण डायरेक्टली अनालॉग सिग्नल आपण फायबर ऑप्टिक केबलला देऊ शकतो का? नाही.
No, ma'am.
पहिल्यांदा ते अनालॉग सिग्नलचं कशात कन्व्हर्जन केलं आपण? लाईट मध्ये. ते कशा थ्रू केलं? इथं एलईडी थ्रू. मग ह्या लाईटला ट्रान्समिट केलं. परत रिसिव्हरला इथं काय जोडलेलं आहे? ऑप्टिकल डिटेक्टर, फोटो ट्रान्झिस्टर. दिस फोटो ट्रान्झिस्टर विल कन्वर्ट लाईट इन द फॉर्म ऑफ इलेक्ट्रिकल सिग्नल. मग ह्याची स्ट्रेंथ कमी आहे म्हणून परत त्याला काय दिलं? एम्प्लिफायरला दिलं. बट वन्स दिस गेन इज ऍडजस्टेड, युअर इनपुट अँड आउटपुट बोथ आर गोइंग टू बी सेम. आता ह्या सिग्नलची फ्रिक्वेन्सी चेंज होत नाही, फ्रिक्वेन्सी कॉन्स्टंट आहे 1 किलोहर्ट्ज. You can note down it somewhere. Frequency is 1 kilohertz. So whatever input signal you are changing, same signal change you may observe at the output side. Okay. So these basic things you please keep in mind. So observation table and that next. आता ह्याच experiment मध्ये digital link पण आहे. So once again I am requesting you, please attend the practicals in the offline mode. So that it will be clear to you. आणि OC चे प्रॅक्टिकल खूप सिंपल आहेत. कनेक्शन्स पण थोडे आहेत. जर तुम्ही हार्डवेअर किट वरती ते एकदा बघितले प्रॅक्टिकल तर इझिली यू विल बी एबल टू अंडरस्टँड द प्रॅक्टिकल्स अँड यू कॅन परफॉर्म इट. In the afternoon for one batch, I explained it on the hardware easily. Within half an hour they were able to perform the initial. त्यांना तर analog link, digital link, both practicals I have explained and they were able to perform it very easily. So digital link and observation graph वगैरे ते पार्ट आपण नंतर बघूया. That lab manual I will share on your in your study material. So please go through that so that you will get the overall idea about the practicals. Okay. So we will stop here today. You just wait 1 minute. I will take the screenshot of your attendance. Okay. So you can leave now. Any doubt? Clear झाले का तुम्हाला काय सांगितले ते आज सांगा मला.
Yes, ma'am.
Yes, ma'am.
Okay, you go through that video and whenever you will be in the college, please come in communication lab, see that kit so that you will understand the next part. जरी ह्याला प्रॅक्टिकल ओरल एक्झामिनेशन नसली एक्सटर्नल तरी ह्याच्या टर्म वर्क मध्ये प्रॅक्टिकल परफॉर्म केल्याशिवाय टर्म वर्कचे मार्क नाही आहेत बरं का. टर्म वर्क फॉर्म्युलामध्ये प्रॅक्टिकल परफॉर्मन्सला मार्क आहेत. सो डोंट टेक इट इन दॅट डायरेक्शन. पीओई नाहीये म्हणजे आपण प्रॅक्टिकल नाही केले तरी चालतंय. सो डोंट टेक इट इन निगेटिव्ह वे. Try to understand the things. Okay, so we will stop here. Thank you.